This is November number corner coordinate grids, and we will be studying triangle C, which is days 11 through 15. Your page should look like this. At the top, there should be a chart that says triangle C on the left side, and across the bottom should be the triangles for days 11, 12, 13, 14, and 15. Go ahead, look at triangle for day 11 and sketch it here in the box. Alright, now to figure out the kind of triangle based on the angles, we need to look at each of the angles and see if they are greater than, less than, or equal to 90 degrees. So we can easily see this one is way less than 90 degrees, and this one is also less than 90 degrees. So we really just need to look at this one to figure out if it is greater than or equal to 90 degrees. Now, usually I take the edge of my paper and line it up so that the flat edge is along one side like this, and then put the corner on the corner of the angle that I want to see, and then my paper will show me a right angle or a 90-degree angle. The corner of the paper will. So I can see here, if I did that with this triangle, that this angle is greater than 90 degrees. So that means that it is an obtuse triangle because one angle has more than 90 degrees. Now, when looking at the sides of the triangles, we need to figure out, are all sides equal? No, we can see they're different lengths. Are two of the sides equal lengths? Nope, they're all different. So that means that it is a scalene triangle if all three sides are different. Now it's time to look at the ordered pair. Let's start with green. Our green ordered pair is right here. If we go down to the x-axis, it is at 4. And if we go left to the y-axis, it is at 6. So our ordered pair is 4, 6. Because remember, we always have to do x, comma, y. Now the blue point. Go down to the x-axis, 6. Over to the y-axis, 4. So our ordered pair is 6, 4. And lastly, the purple point is on the x-axis at 0. And on the y-axis at 4. So we have 0, 4. Because this is our first day, there will be no transformation. Now I want you to use your paper and the grids at the bottom, and please do the sketch, the kinds of triangles by angle and by side, and all three ordered pairs for day 12, 13, 14, and 15. Pause the video. Once you have finished this part, continue with the video and I will teach you the transformation part because that is the part that seems to be the most difficult. Alright, to begin to find the transformation of the shapes over the course of the 5 days, we first need to plot the ordered pairs from day 11 on the day 12 coordinate grid so that we can see which way it has moved. So I'm going to start with my green ordered pair. it was at 4. So I'm going to start at 4 and 4, 6. So I'm going to go up until I get to 6. So my green ordered pair started here at 4, 6. Then my blue ordered pair was at 6, 4. I'm going to start at 6. I'm going to go up 4. The blue ordered pair was at 6, 4. And the purple ordered pair was at 0, 4. 0, 4. Now I'm going to connect my lines. And we can see from day 12, or from day 11, the first triangle, to day 12, that the green point moved to the right 1, 2 spaces. The purple moved to the right 1, 2 units, and the blue moved to the right 2 units. So in our transformation box, we are going to write, it's called translation, when a shape slides to another place on the coordinate grid. So just like this, it slid over. So here we're going to write that it translates how many spots? 2, and we call them units. Which direction? Right. So it translates 2 units right. And in case you forgot, transformation is any way a shape moves on a coordinate grid. So write that down also. Now, if you have not done day 13, these first 4 boxes, do that now. I'm going to help you with the transformation. So, just like before, we have to take our points from day 12 and plot them on the day 13 coordinate grid. So let's look at it. The green point first is at 6, 6. So on day 13, I'm going to plot it at 6, 6. There's my green point. Now let's do blue. Blue was at 8, 4. So we have 8, 4. And purple was at 2, 4. So we're going to plot on day 13. 2, 4. And then we connect our lines. Now look very closely. We go from the one we drew and we move up to the point that is on this chart already. So we start at the green point and we go up 2 units. Blue, up 2 units. Purple, up 2 units. So since it's still sliding, it'll still be translates 2 units up. All right, make sure that you have day 14 sketched, the kind of angle and sides that it has, and the ordered pairs. So again, we look at the green ordered pair first, and on day 13, it was at 6, 8. So that's where we're going to put it this time, 6, 8. Then we have our blue ordered pair, which was at 8, 6, which happens to be in the exact same spot that it still is. And our purple ordered pair was at 2, 6. So 2, 6. And draw your lines. So you should be able to see the blue point is still in the same spot. So what has happened is that our triangle has moved from this position to this position, and the blue point has stayed the same, so we know that the purple point moved and the green point moved. And when only part of when one point stays the same, we call that rotating. So we can see that when we rotate, when the triangle moves and one point stays the same, we write rotate. Then we need to write how many degrees. So let's look at the green line. That's what's going to help us the most. The green line started off going horizontally, and then it moved vertically. So from here to here, we have a right angle. And a right angle is 90 degrees. So it rotated 90 degrees. And we use the terms, a clock goes like this, and the hands move this way. But in our triangle, you can see that they're going the other way. So if it moves the same way as a clock, we call that clockwise. If it moves the opposite way, we call it counterclockwise. So in our box, we're going to write rotates 90 degrees counterclockwise. And lastly, from day 14 to day 15, we're looking at how our triangle has moved. And some of you might be able to see it, but we're still going to plot the points. So we started off, our green point was at 6, 4. So we go 6, 4. Now, our blue point is at 8, 6. So we go 8, 6. Oh, it's in the same spot again. And the purple point was at 8, 0. So 8, 0. Oh, and that one is in the same spot as last time also. Then make sure that you're drawing the line. So the purple one's here, the purple one is here. The blue one is here, the blue one is here. And the green line is in the same place. So we can see that it went from here to here, and here to here. And we call that flipping, or in the math, the geometry word is, from our geometry vocabulary, when it flips a shape over the x-axis or y-axis, it is called reflection. So in this box, we're going to write reflects over the, and we're going to decide, it reflects over the green line, which is that the x-axis or a y-axis? It is the y-axis, because it goes up and down. That's all for today. Make sure your whole paper is filled out and that all of your drawings are down here so that I can see that you know how transformation works.